Kimi K3 has arrived with a dangerous marketing combination. It is enormous, it is cheaper than the leading proprietary models, and Moonshot's charts place it near the frontier. So is Kimi K3 now better than GPT-5.6 Sol and Claude Fable 5? The honest answer is more useful than a winner graphic. Kimi K3 appears competitive enough to deserve real consideration, but the public evidence does not support calling it the universal winner. Even Moonshot says K3 still trails GPT-5.6 Sol and Claude Fable 5 in overall user experience. That admission should frame the entire comparison. Let us start with what each model is trying to be. Kimi K3 is Moonshot's open frontier model. Its strongest story is scale, long context, native vision, long horizon agent work, and aggressive pricing. GPT-5.6 Sol is OpenAI's flagship for complex professional work. It has a context window slightly above 1 million tokens, broad tool support, and deep integration with Codex and the OpenAI Responses API. Claude Fable 5 is Anthropic's model for ambitious, long-running coding and knowledge work. Anthropic emphasizes careful planning, autonomous work over long periods, high-fidelity design implementation, vision-based checking, and self-verification. On paper, all three occupy overlapping territory. That is exactly why benchmark screenshots can mislead. Moonshot's own benchmark footnotes show that different models are sometimes evaluated through different agent harnesses. K3 may use Kimi code, Claude may use Claude code or another harness, GPT may use Codex. Some numbers come from official leaderboards, others come from provider launch posts, some are averaged across runs, some select the best harness available for each model. Those results are still useful, but they are not one perfectly controlled race. The harness matters because the model is not working alone. The harness decides which files are visible, how tools are described when context is compacted, how failures return to the model, which commands are allowed, and whether the model can revise its plan. A model score is partly a model result and partly a system result. That means the right comparison has 5 dimensions. First, coding execution. K3 is explicitly built for long engineering sessions, large repositories, terminal orchestration, and visual feedback. Moonshot reports strong results and impressive internal demonstrations, including kernel optimization and compiler development. GPT-5.6 Sol has the advantage of Codex, a mature execution environment with repository inspection, shell access, patch application, tools, and multi-agent workflows. Claude Fable 5 has Claude code and a strong emphasis on long-running projects, self-written tests, design fidelity, and visual checking. There is no honest universal winner here without running the same repository task with the same permissions, scoring, and review rules. Second, context. K3 supports up to 1 million tokens. GPT 5.6 Sol supports approximately 1.05 million. A large number does not create automatic repository understanding. What matters is recall, navigation, context management, and behavior after hundreds of tool interactions. K3 has one unusual caveat. Moonshot warns that its quality can become unstable if the harness does not return the complete thinking history, or if a session switches to K3 midway. That makes harness compatibility especially important. Third, visual work. All three can consume images. K3 and Fable are both marketed around using vision to inspect generated interfaces. GPT 5.6 also supports image input and is positioned for design and computer use work. The deciding test is not who can describe a screenshot, it is who can convert a visual target into a narrow code change, render the result, notice the mismatch, and correct it without damaging the rest of the application. Fourth, Control Moonshot warns that K3 may act too proactively when a task is ambiguous. That can be useful during an open-ended research job and dangerous inside a production repository. Claude Fable 5 is also described as proactive, while Anthropic applies safeguards and fallback behavior in sensitive domains. GPT 5.6 provides a broad tool surface, which makes permission configuration and approval gates equally important. The strongest model is not always the safest agent. Capability and authority must be evaluated separately. Fifth, price. K3 costs $3 per million uncached input tokens and $15 per million output tokens. GPT 5.6 Sol costs $5 for input and $30 for output. Claude Fable 5 costs $10 for input and $50 for output. On token price, K3 is the clear low-cost option among these three, but tokens are not the final unit. The final unit is a successful task. A cheaper model that takes 3 failed attempts can cost more than an expensive model that produces 1 correct, reviewable patch. A strong model that creates a giant unsafe diff can be more expensive than all of them once a human cleans it up. So here's the practical verdict. Use Kimi K3 when cost, open weight direction, huge context, native visual work, or access to Kimi's agent ecosystem matters, and when you can place explicit boundaries around its actions. Use GPT-5.6 Sol when you want frontier reasoning inside the OpenAI and Codex execution stack, especially for tool-heavy professional workflows. Use Claude Fable 5 when the job benefits from careful planning, extended autonomous work, design interpretation, and the Claude code environment, and when the higher price is justified by fewer misunderstandings. And do not choose permanently. Run one fixed task through each system. Measure correctness, tests, diff size, human repair time, token cost, wall clock time, and unauthorized changes. The best model is not the one with the tallest launch bar. It is the one whose failures your workflow can detect, contain, and correct. Kimi K3 has not ended the comparison. It has made the comparison worth running again.